66 million years ago, a rock 12 kilometers wide ended the age of dinosaurs. It released energy equivalent to 1 billion nuclear bombs. It darkened the sky for decades. It killed 75% of all species on Earth. That was a medium-sized asteroid. Tonight, we're asking what happens if something 10 times bigger, the largest asteroid in our solar system, breaks free from the belt and heads directly for Earth. The science is almost impossible to comprehend. Let's try anyway. The largest asteroid in our solar system is Ceres, 940 kilometers across. It's so large it's classified as a dwarf planet. For scale, the asteroid that killed the dinosaurs was 12 kilometers. Ceres is 78 times wider. The energy released by a Ceres-scale impact would be so far beyond the dinosaur killer event that scientists don't have a standard comparison for it. We're talking about an impact that doesn't just cause an extinction event, it fundamentally alters the structure of the planet itself. The crust, the mantle, the orbit, everything changes. If Ceres somehow left its stable orbit and headed toward Earth, we'd have years of warning, maybe decades. Astronomers would track it obsessively. Every space agency on Earth would be mobilized. The question wouldn't be whether it's coming, it would be whether anything could stop it. Current planetary defense technology, kinetic impactors like NASA's DART mission, which successfully redirected a small asteroid in 2022, works on rocks measured in hundreds of meters. Against something 940 kilometers wide, moving at tens of kilometers per second, our entire planetary defense capability would be completely useless. We would watch it come, and we could do nothing. Months before impact, Ceres would be visible to the naked eye, growing from a bright star to a disk to something that fills a significant portion of the sky. Its gravitational influence would begin affecting Earth long before contact. Tides would intensify. The moon's orbit would shift slightly. Earthquakes would increase in frequency as Earth's crust responded to the changing gravitational field. In the final days, the object in the sky would be larger than the full moon, then larger than the sun. The last sunsets on Earth would be unlike anything in human history. A sky dominated by an approaching world, glowing red from solar reflection, silent and inevitable. The moment Ceres hits the upper atmosphere, the energy release begins. The compression of air ahead of the impactor creates temperatures hotter than the surface of the sun. In the atmosphere, before anything has even touched the ground, the shockwave expands outward, at supersonic speeds. Everything within thousands of kilometers of the entry point is flattened by atmospheric pressure alone, before the impact itself. The sonic boom circles the globe multiple times, then the rock hits the surface. The energy released in the first second of contact is beyond any natural event in Earth's history. The crust at the impact site vaporizes instantly, not melts, vaporizes. A crater the size of a continent begins forming in real time. Molten rock is ejected into orbit at escape velocity. Leaves Earth entirely, some of it falling back as a global rain of fire hours later. The mantle is exposed. Magma floods outward from the impact site in waves. The shockwave traveling through the solid Earth triggers every fault line on the planet simultaneously. Every volcano erupts. Every earthquake zone ruptures at maximum magnitude. The entire surface of Earth becomes geologically active within minutes. The ejecta that reached orbit begins re-entering. Superheated rock fragments rain down globally, not as meteors, but as a continuous bombardment that raises surface temperatures worldwide to oven levels. Forests ignite simultaneously across every continent. The oceans on the side opposite the impact are driven into mega tsunamis thousands of meters high by the shockwave traveling through the mantle. The atmosphere itself is partially stripped, the upper layers pushed away by the impact energy, thinning the air pressure at the surface. Within 24 hours, the surface of Earth is unrecognizable. The impact site is a glowing wound in the crust. The rest of the planet is on fire. If anything survives the immediate impact, deep ocean organisms near hydrothermal vents, bacteria in deep rock, they face decades of impact winter. The debris cloud blocks sunlight globally for years. Temperatures plummet, photosynthesis stops. The food chain collapses from the bottom up. But here's what's different from the dinosaur extinction. At this scale, the impact doesn't just cause a winter, it potentially strips enough atmosphere to permanently alter Earth's air pressure. It injects enough material into the upper atmosphere to change the planet's albedo for centuries. The Earth that emerges from this event, if it has any life at all, is a fundamentally different planet. Smaller atmosphere, different chemistry, a fresh start for whatever survives underground. Here's what puts this in perspective. Earth has already survived impacts almost this large. Early in solar system history, during the late heavy bombardment 4 billion years ago, Earth was hit repeatedly by objects potentially hundreds of kilometers in size. Life survived. Not complex life, but the chemistry of life, the basic building blocks, persisted through events that make the dinosaur killer look minor. Life on Earth is not fragile in the way we sometimes imagine. It's extraordinarily resilient at the microbial level. The question an impact like this raises isn't whether life continues, it's whether intelligence gets another 4 billion year chance to try again. The asteroid wiped everything on the surface, but what's underground survived. Because Earth has a shield most people never think about, its magnetic field. It protects us from radiation, holds our atmosphere in place, and keeps the planet livable. And right now, that shield is weakening. If you want to know what happens when it fails, that's the next video. Subscribe and hit the bell so you don't miss it. See you in the next one.